Superb workload consolidation is a key capability of IBM System P servers, running multiple AIX and Linux for Power applications side by side in a virtualized environment. Linux programs designed for x86 servers, however, were restricted to that architecture until now. Introducing PowerVM LX86, which enables Linux applications compiled for x86 processors to run without change on IBM's advanced power processor-based systems. Let's take a look at LX86 in practice. Illustrating the components in use for this demonstration, on the left is an x86 processor server. To the right is a power-based System P. Both are connected to the shared storage at the top and are accessing the same directories in the shared disk. Our first step is to install a popular media streaming software package in its native environment on the x86 server. This software is currently available for Linux only on the x86 architecture and has not yet been recompiled for power processors. The binary files created by this installation are accessed concurrently by the System P server. In the center is a client workstation that will remotely connect to both the x86 and power-based servers. A terminal window on the left will log into the x86 server, while the terminal window on the right is logged into the System P server. We'll execute the media streaming software in both environments. Below the x86 terminal window is a web browser that will connect to the media stream provided by the x86 server. And to its right is a browser which will connect to the stream from the System P server. Let's begin the demonstration. The first thing we're going to do is launch the media streaming software on the x86 server. Remember that this software is located on shared disk. Once that software is running, as it is now, we'll launch the exact same code on the power server from the same directory on that shared storage. This is not a simple duplication. It is in fact the same physical executable program. Of some interest here, you'll notice that we did not enter a special x86 environment on the power server. Launching that application within the Linux on Power environment automatically identifies it as an x86 application and executes it under LX86. Now that both media streamers are functioning, let's launch some client activity. In the browser below the x86 server, we'll launch a video player that will access that streaming software. At the same time, in the other browser, we'll link the same video as it is served by the power-based system. You'll notice they're very seamless, they're smooth, they're very clean. Both videos are drawn from the same shared disk by two different instances of the same media streaming software running on two different servers. One being native x86, the other running the same native x86 application in the LX86 environment of Linux on Power. The result? A very smooth client experience. Because we're running on a power processor, the LX86 environment inherits many of the reliability, availability, and virtualization characteristics that are engineered into that platform. So let's take a look at a piece of that. Another part of the PowerVM Enterprise Edition is partition mobility. That enables the move of a running partition from one System P server to another. As we start that migration, you might ask, why would I want to do that? Well, put very simply, it allows you to take the server down for service, maintenance, upgrade, without taking any client applications down with it. You might want to go green, shutting down some servers to reduce the power consumption within the data center, or you could load balance among your inventory of servers, all without affecting application availability. As that partition is in the process of moving from one server to another, let's describe what's happening. Partition mobility is a function of PowerVM Enterprise Edition. It enables AIX53, AIX61, and Linux on Power partitions to move between Power 6 processor-based servers as they continue to run. That move is affected by passing all of the partition characteristics from the source to the target server, establishing a new partition on the target, and then copying the memory to that target. This all happens in the background with little to no effect on the applications as the partition is moved from one server to the other. As the migration approaches 100%, watch the video playing in the browser, and you'll see a very fluid transition between servers with no discernible effect on the client application. Now that we've reached 100%, the Linux on Power Partition and the LX86 function are now running on a physically different server, while the video continues to play seamlessly in the browser and the user is unaware that any change has taken place. What you have just seen is only two of the many system optimization functions offered by PowerVM. Tying this together, LX86 supports the installation and execution of most x86 Linux applications on Linux for Power. It runs on Power 5, Power 5 Plus, and Power 6 processor-based systems, as well as IBM Blade Center with JS21 or JS22 blades. LX86 is a standard feature of all PowerVM editions, which extend rich virtualization to existing x86 Linux applications and enables partition mobility on Power 6. In short, LX86 gives you a greater choice of the applications you can run and a greater choice of where you can run them.